So, now we're going to move into the fair data section, and the first talk we're going to hear about work that's going on at the ESRF.
Ok. Tu veux le truc comme ça? Tu veux utiliser la... Okay. So if you open it with Firefox, and then go, yeah? Presentation mode, and then you can change what sort of thing.
Okay, thank you. So good morning, everyone. So today we will explore how the ESRF data portal enhances fair data management through the integration of process data. So I'm presenting on behalf of my colleagues, Alex Nemaria, Maël Gaonac, and Guillaume Guénier. My name is Marjolaine Bodin, and I work in the software group at the ESRF. So data is the cornerstone of scientific research, and it represents our most significant output. Archive data must remain available and interpretable for the future use. So the ESRF achieves this goal by implementing the FAIR principles: findable, accessible, interoperable, and reusable. So a few dates. Our data policy was adopted in 2015 by the ESRF Councils, and 2 years later, we launched the first version of the data portal, so data.esrf.fr. And in 2019, we integrated the e-logbook. Last year, our data repository achieved certification by the Core Trustees organization. So it was a significant step by ensuring sustainable and trustworthy data repository. Earlier this year, we updated our data policy, and we are about to launch a new version of our data portal. So one of the key changes of our updated data policy is the inclusion of process data. So to better manage them within the portal, like offering a tailored display based on beamline or on technique, we changed the portal architecture to implement a more flexible and scalable application that we call in Nexus of Originality Data 2. So why do we aim to integrate process data? So first, we already have process data in our portal that we have added on request, because most of the time people want to reference their data in a publication, so mint a DOI. Process data help us, help scientists to assess the quality of the data, and they can also assist them to fine-tuning a beam time experiment, leading to more efficient use of beam time. So this demand is growing because users are managing a large volume of raw data, and especially after the EBS upgrade, also with the number of samples continuously rise. So automatic data analysis become also more common. So now we have our workflow system, eWorks, installed at many beamlines at the ESRF, and it supports uploading of the process result to the data portal. So we have a talk about eWorks this afternoon from my colleague Loïc Eder. And also users may want to associate their manually analyzed data with their raw data for publication, for example, or they want to reprocess their data with different parameters. We have been managing process data for the structural biology community since quite a long time through the iSpyB LIMS system. So it supports experiment preparation. Oops, sorry. Experiment preparation, and it displays specialized data visualization for MX experiments. But it's difficult to extend it to other techniques because, as you can see on the snapshot, the iSpyB database contains more than 100 tables, mainly designed for MX or for biosacs. And if we want to cover all techniques at the ESRF, it seems overly complex. So at the same time, we already have the raw data in our data portal, thanks to the data policy. So the information is already there, but we don't have a specific display. And we believe that integrating process data within the portal is the most relevant and efficient solution to moving forward. So we aim to support multiple links between raw and process data. So this range from the simplest case was one raw dataset, we generate one process dataset, to more complex scenarios involving multiple raw datasets and multiple process datasets. What is the system behind? So the entire system is called DRAC, which stands for Data Repository for Advancing Open Science. One of the main components is the metadata catalog ICAT, which is developed and maintained by FCFC and the ICAT collaboration. We have also multiple API services, collectively called ICAT+. So we have dedicated service for the catalog, for the sample tracking, logbook, statistics, and more. All ESRF beamlines follow a unified process to push data and metadata via the ingester. And the ingester is also in charge of retrieving and synchronizing information from our user portal, like experiments, users, and samples. On the user side, data is accessible via the data portals, which includes different modules. So one module for the portal, the core module for the portal itself, and dedicated module for the logbook, sample tracking, and the specialized module for the data display like CryoET or MX. Process data are also available through two dedicated portals, the Human Organ Atlas and the Paleontology database. The main technology stack, so we have an ICAT Oracle database, and we are using MongoDB for sample tracking and logbook. ICAT is developed in Java. ICAT Plus is an Node.js application. The ingester relies on the message broker ActiveMQ, an Apache Camel. So it's developed in Java, and we are utilizing Python library. On the front-end side, all applications are built with the React framework, with TypeScript. And the data portal leverages the module federation, so to include the different modules, and to allow us to have modular code bases with incremental upgrades and independent deployment. So as I mentioned, the display of the data is configurable in the portal for each beamline, technique, and date. So we have a generic approach here, so you can see our raw data and the process data that have been generated. And we have specialized displays. So you have an example for the cryo electron tomography on CM01. So you have a raw data, typically alongside with two process data, the motion correction and the CTF. And this is for each angle, you will have the same display. Oops. Sorry. For the MX use case, so iSpyB offers a very high specialized display, so we wanted to be sure that we can replicate such a display in the data portal. So raw and process data are displayed together as actions, so user can see their actions or the workflow steps here, and the estimated best auto-processing based on criteria that can be adjusted in the UI. And we were also able to manage more complex links between process data. So you have an example here of one process data coming from one raw data set, another process data, and they have been merged together in another process data here. So all this display is driven by metadata, which is associated to each data set. So the metadata are stored as key value pairs in ICAT database, or sometimes on files that are stored on the disk. So you have an example of the file, a JSON file here for a characterization dataset. So MX view, users can see well, it's not completely real-time, but on real-time, once the workflows are completed, they can see their result in the portal, and they can see if the crystal is diffracting or not. They can adjust the parameters as needed, and they can see quite easily the quality of their data. They have also a summary view, where they can see if their samples have been collected or have been processed, so they can follow their experiment during the beam time. The data portal also offers the ability to reprocess the data. So here, the user will see the eWorks available workflows. So I have only one here, but then they can input the parameters they want to change. So for instance, the space group or the limits. They can exclude data ranges directly from here from the dotted plot and run the workflow. Once completed, it is displayed in the data portal as a new data set. This is a prototype we developed for MX, but we believe that it can be generalized for some other techniques. I just want to highlight briefly some other feature we have in the data portal. So the electronic logbook, which is a timestamp logbook at the level of the experiment or at the beamline level for our beamline staff. We have notification from the acquisition software or from the accelerator that are automatically sent to the portal, and users can also comment to enrich the understanding of the experiment. I will not spend too much time on this. We have also unified the sample tracking over all beamlines. So because until now, MX sample tracking is done through ISPy-B, and while the other beamlines are using the data portal. So now we have a generic solution within the data portal. And we have also introduced the notion of processing plans, so users can choose which pipeline, for example, they want to use on which sample. So this is for MX, but it's configurable for each beamline. We have also DOI, so at the end of an experiment, a DOI is automatically minted, but users can generate custom DOIs for any subset of the data, and specifically here for process data, and then the raw data will be automatically linked to their process data. We have also statistical tools, so for data managers or beamline staff, so they can monitor the volume of the raw and process data within an experiment. Here you have a heat map representing all data for all beamline at the SRF over the past year. We have also sample tracking statistics or logbook statistics. Two final slides for the dedicated portals. So here it's a human organ atlas, which presents data based on studies using the hierarchical fast contrast tomography. So you have a link to the article here if you want further information. So the user can search over the metadata stored in ICAT, like the scan parameters, the sample, and the organ, and so on. And we can also integrate in this portal advanced visualization tool like NeuroGlancer to display volumetric data. So this is open process data that are public, no need to log in. The second one is the paleontology database. So the paleontology database has existed since 2011, but this year we have integrated it into DRAC. In collaboration with the scientists, we added some geographical, geological, temporal, and taxonomical metadata to enrich the dataset, allowing users to search over multiple criteria. So we have built, DRAC is built over a robust architecture to manage various types of process data. Managing process data enhances the fairness of data. We know we have no structured metadata, full transparency of data provenance with strong links between raw and process data, and we have introduced a clear documentation of processing steps. Real-time assessment of data quality boosts productivity and ensure efficient use of beam time, enabling rapid adjustment to the experimental setup and prioritizing samples or settings that provide the most valuable data. For the next step, so we aim to integrate more techniques. So we have the SSINX techniques ongoing. And this is all related to the work we are doing the integration of ontological definition of experimental techniques. So we have a talk of Bodin this afternoon about that. We aim also to improve the processing plan, and over the next 2 years to develop a new dedicated portal for the cultural heritage. So, by the way, we have a position open for this, so you can click on the link or just contact me for this. And we want also to improve the logbook to keep track of processing data. So behind track, we have the ESRF team, so thanks to Alex Demaria, Maël Gaonac, who mainly work on the UI of the data portal, Guillaume Guéné, who focuses on the dedicated portals, and of course Andy Goetz, who plays a crucial role in advancing fair data and open science at the ESRF. Thank you.
Thank you very much. We've probably got time for one quick question.
Yeah, thank you, Marjolaine, for this very impressive presentation. We can say that you are almost already ready at ESRF. And I have one question. You said that DOI are automatically minted. Does it mean that you have already the agreement from your scientists to
Sorry?
mint does it mean that you have already the agreement of your scientists to mint automatically DOIs for all the datasets produced at their beam
Yes,
lines?
it's part of the data policy. At the end of the experiment, so apart industrial experiment, of course, but for academic experiments, the DOI is automatically minted at the end of the experiment, but the data is still under embargo during 3 years. And they will be open after the 3 years.
Thank you. Let's thank the speaker again.